Hello everyone, and welcome to this Visual Studio for C++ developers session. Thank you for choosing to spend your time with us. My name is Daniel Moth, and Steve Carroll is going to be joining me for some cool demos later on. And before I move on, you guys should realize that this is the most important slide. And that's because Steve and I manage the C++ product team, so if you have any feedback on the direction we're going, our emails are up there. So even if it's just praise to say how well we're doing and that you love everything that's going on, you can email us at daniel.moth@microsoft.com. If you have abuse, criticism, bugs, you want to throw stuff, email us at steve.carroll@microsoft.com. That's how we split the responsibilities. I get the praise, he gets the complaints. But seriously, this is the most important slide. You should write down the URL that's on this slide. So that's our blog address. And everything that is going to be in the rest of the talk, URLs, content, and so on, are in these slides that we're going to upload to that blog at the end of the day. So you don't need to write down anything during the talk. You just need that one URL and you're set. You're golden. So very important. Take that down now. Now, over the weekend, we added to our blog our annual C++ developer survey. And I wanted to repeat that here. So please go to aka.ms/CppCon and take the developer survey. If you do that, you'll have a chance to win this, what's on the slides right now, which is the Xbox One S bundle with games. We're going to actually physically give that out on Friday to the lucky winner over here. Even if you don't want the Xbox for whatever reason, maybe you got too many at home, I don't know, please do take the survey because it does help us influence the direction of where we're taking things, which is better for you. And even if you're not using our products, help others by giving us your feedback. It's worth it. So please do that. The other thing I wanted to do before we get into the talk is share a bit about our mission on our team. So like I said, we're the C++ product team at Microsoft. We're in a group called the Developer Division, or DevDiv for short, which is all about developers. That's all this group does. And specifically, our goal is to improve the lives of every C++ developer out there. Now, not everything that we do is applicable to every C++ developer, but a lot of it is. So we stand by that broadly scoped goal. And the way that we try to do that is via various ways. One way is by enthusiastically participating with the C++ standard to improve the language itself for every developer in the world. So that's one thing. Another thing we do, of course, is ship and improve as much as we can the Visual C++ compiler and libraries toolset, so MSVC. And our goal with that is for it to be the best choice on Windows for targeting Windows. The other one that you'll be familiar with is the Visual Studio IDE, the Integrated Development Environment. So our goal there is to have the best IDE on Windows for targeting any platform. And finally, we continue to improve Visual Studio Code and the C++ extension to Visual Studio Code, which is applicable to all developers as it runs on all platforms. So these are 4 of the areas where we invest a lot of our energy towards our mission. Now, we're not going to talk in this talk about the first point anymore, about the C++ standards. I'm sure many of you know that we send around 8 people at each one of the 3 meetings that happen every year as part of the standards. We actually review proposals, participate in proposals, we lead proposals ourselves. And not to be underestimated, we actually validate early versions of proposals with our compiler so the end result can be better for everyone, both in the compiler and the library space, in fact. So we're not going to talk about that. Instead, what we're going to focus on here are the middle 2. And before we go and focus on the middle 2, I wanted to just touch on the last one for those of you that don't know about it, which is Visual Studio Code. So Visual Studio Code is not an IDE. It's not an integrated development environment. It's an editor. It's a fully featured editor. It has source control integration, it has debugging support, it has extensibility, and it's cross-platform. It runs on Linux, Mac OS, and Windows. So if for whatever reason you don't want to use Visual Studio, can't use Visual Studio, and your upbringing is more like Vim or Sublime or Emacs, something like that, then this is the tool you want to check out. And if you want to learn a lot more about this, we have a talk here at CppCon, so you should catch the recording of that when it goes online. And the reason I say you should catch the recording is because it's taking place right now, and you cannot be in 2 places at the same time, so stay here, you don't have to go there. You can catch the recording when it goes online later that Ronglu is given. So that's Visual Studio Code. All right, so how are we going to spend our time in here? Well, we've structured this talk into 2 parts. In the first part, we're going to focus on MSVC, the compiler and libraries toolset, because we kind of treat that as its own product, because you could absolutely be using that on its own without ever going near Visual Studio. And then the second part is going to be with about Visual Studio, which many people use in conjunction with a compiler. But you can actually use Visual Studio with any compiler that you like. So it's a separate thing. And in terms of what we're going to talk about, you can see on the slide the kind of things that we're going to drill into. But you should know that the first part is kind of shorter, I should say, than the second part. And it's all slides. And then on the second part is going to be mostly demos. So that's kind of like what we're going to go through. So just a quick question as we dive into the first thing. How many people in here use for one of the C++ code bases the MSVC, our own compiler? Can I see a show of hands? Is that everybody? I'm trying to see. Maybe try the other way around. Who isn't using it? Can I see a show of hands? Okay. Yeah, so you guys are here to do competitive analysis. I get it. That's fine. So we'll talk about it. So for those of you that do use it, I'm sure you want to know how we're doing against the top priority for the MSVC compiler team, which is conformance with the C++ standard. So we're not going to go into any of the features on this slide. All we're going to do is use it in order to report progress, how we're tracking against it. So all that white text that you see in the blue boxes are all the things that we completed as of the Visual Studio 2017 RTM release in March or earlier. And with that release in March, we delivered on our promise to be conformant with all the new features introduced by C++ 11 and C++ 14, as the check marks indicate up on the slide. Now, since that RTM release of the compiler with Visual Studio in March, we've shipped 15.1, 15.2, and in August we shipped 15.3, the version 15.3 of Visual Studio 2017. And with that, even more conformance came out, the ones that are in the yellow boxes. So if some of you are on Visual Studio 2015, that's a whole bunch of conformance that you're missing out by not using our latest compilers. That should be incentive for you to move. Now, at the moment we have 15.4 preview is out, and in November we're going to have 15.5. So with that release of 15.5 in November, we'll actually have even more conformance implemented, as the purple boxes are showing. And notice that on this slide I do not have a C++ 98 swim lane, but there is one feature in there that many of you I know care about, and I'm seeing nods about it already, which is the two-phase name lookup. And I'm delighted to share here that with that release we're actually tackling that as well. And this is part of our rejuvenation effort for our compiler code base, which is a very mature code base. So by introducing the ST-based parser, we're able to tackle that finally and get that out there. Now, 15.5 isn't going to be the last update to Visual Studio. There's going to be a 15.6. We're not imaginative with the name, so it's 15.5, then it goes 15.6. And with that release, I'm excited to confirm that at that point, once we finished all the brown boxes across the compiler and the IDE in IntelliSense, we will actually be conformant with the C++ 17 standard and we'll be completely caught up. So that is our goal there. Now, beyond the actual blessed standard, there's also the technical specifications. So the slide had just enough room for that as well. So you can see the color-coded boxes as to how we're doing against that behind the experimental flag, since obviously we don't want you to inadvertently take a dependency on one of these, since the spec is moving itself. So please try the experimental stuff, give us feedback, both for our implementation, but also for the spec itself. So you can see there, I mentioned on the slide somewhere permissive minus, and we talked about that last year, but I wanted to touch on it again here for those that don't know. Basically, permissive minus is a switch that puts the compiler in a mode where it will honor and enforce pre-C++ 11 standards. It's off by default because we need to give the community, the ecosystem, and the open source libraries enough time to get used to the fact that our compiler would not actually by default enable Microsoft-specific extensions and Microsoft-specific behaviors, because all the template code has a chance to break under this. But wherever we encounter code bases that don't build with permissive minus, we go and fix that. So the biggest achievement recently, I think, was the actual Windows SDK headers. So for RS3 that's coming next month, we've actually made that build completely clean with permissive minus. And also with new projects that you create in Visual Studio, because they're new code, we actually have permissive minus on by default. I'm not going to go through all the other switches. We talked about those last year, but the point here is that you can adopt the conformance that you want at your own pace. It's not like a big switch where you got to go fix everything and make all of your code base conformant. If you want to do that, you can, but you can take chunks and move at your own pace towards that. So this helps with upgrades. Now, we're talking about all this conformance, and what's the easiest way for you to feel the benefits of that? And that is by actually using open source libraries or libraries that previously wouldn't compile with our compiler that now do. And some of these were in that category. Now, these libraries here is just the example of what we build live daily. So we don't just go and test these libraries once. We take the live branch with our live daily bits and we build them multiple times under various different modes. And what we do is we clean them as we go along, removing if-defs and anything that's protecting against conformance gaps in our compiler. As we plug those gaps, we go and fix those code bases so they can be clean and portable and readable and so on. And you'll notice, to my point earlier, that the permissive minus is 55 out of the 58. So I asked the team, I'm like, how about the other 3? And I said, well, we have pull requests out to those project owners that if they accept, their code will be clean and it will build under permissive minus. So we're actively helping here the community come forward. Maybe in the past we weren't always the best citizens in the world, but now I hope you can see that we're really trying real hard to make sure the right thing happens out there. So that's about conformance. Sticking to the same theme of improving your code, now that we're closing the gap on our conformance goals, we can spend more time on other things such as code analysis or compiler diagnostics. So last year in this talk that we did, we had this slide, so I'm not going to repeat it, but it was the beginning of us starting to invest in the compiler diagnostic space. Since then, we've released around 24 deliberate improvements to warnings and errors, and I wanted to share a few of those. So if you look here on the slide, in the first column, there's the code, and in the second column, you can see the error that you would get, which was basically just a syntax error where we just encountered something that we weren't expecting. And in the last column, you can see the improvement with a new diagnostic. So you can see up there, it says, a use of dependent template name requires template keywords. So plain English, and it really helps you actually know exactly what's going on. Also notice the little caret, the upwards pointing arrow. I'm told by our developers that we do there better than other compilers in terms of pointing exactly where the issue is. So you can go verify that for yourselves. And before we move on, if we look at the last example there, that's a case of ambiguous initialization order where we wouldn't even give you an error, and now we actually tell you again in plain English what's going on. So beyond the warnings, other things we're doing to improve your code is the C++ code check analysis tool. So the C++ core guidelines were announced by Bjarne in this conference 2 years ago. And we demonstrated then type and bounds checkers and also a preview of the lifetime checker. And we've been shipping rules or checks, whatever you want to call them, every single time that we ship more of that. And on this slide, I'm just summarizing under which sections or chapters we actually have made most investments recently. So if you want your code to be conformant to the C++ core guidelines, you want to take advantage of that, then please do go and turn this on, because it's not on by default. So go to the project properties like the screenshot shows, and you can turn that on. All right, so now let's switch gears from things that we do in our compiler to help you with your source code to what our backend compiler does in terms of executing your code faster in terms of the code that it generates. So last year we were here and we talked about the new SSA-based optimizer, and we shared at the time that we're seeing about 7% improvement over the eigen benchmarks. And this year we're sharing that, again, spec to case 17, when we look comparing to our previous selves, we're seeing about 9% improvements. And if you're wondering which specific areas that come in, I'm not going to talk about that here, but they're on the slide for the low-level geeks among you, I'll say. They're really interested in what we focused on. These are some examples, and there are folks at the booth that can tell you much more about that. What I'll say before I move on from this is the reason we're sharing these benchmark numbers is because you can go validate it for yourselves, right? But really, internally, the way that we really move the performance needle is with a benefit that we have, that we build all these really large code bases from internal Microsoft teams. If you think about Office or Bing or Core CLR or Chakra or Windows itself, like all those teams have their own performance goals, and they're driving us hard to improve the performance of the code that we generate, and that has ripple effect benefits to all of you for your code bases that run on Windows. But that's harder to share externally to kind of measure the progress, which is why we're also using benchmarks as a way to communicate that. But we feel good about the investments that we're doing here, and we'll do a lot more. All right, on the same thing of performance, but switching from runtime performance to build throughput. Again, if you look at the spec to K17 benchmark, this time from a build throughput perspective, we have around 20% faster than the compiler that ships with Visual Studio 2015 Update 3. So these are all very good reasons for you to want to move to the latest. Now, last year we shared this, and I want to share it again since we're the topic of build throughput, but the debug fast link linker option is now on by default, and that gives you 2 to 4 times faster linking, so that's definitely something that you'll feel the performance of it as you move to the latest version. Also, Incredible have a product that you can go buy from them that parallelizes your build across multiple cores, and we've negotiated a free extension to Visual Studio, so you can just go get that. The only limitation is that if you have more than 8 cores on your development machine, it's not going to use those as it goes and builds. So you should absolutely go check that out. So at this point, that's all I had to say about the MSVC compiler and libraries tools. And I've kind of started cheating because I'm talking a bit about Visual Studio here, and we touched on that when we talked about the C++ code check analysis tool. So now we're going to really go and switch and talk about Visual Studio itself. But before I do that, does anyone have any pressing questions on what you've heard so far? Yes?
What about the /caret option that you mentioned? That once you plug it, is it on by default or shall we opt in for it?
I can't remember if it's on by default. This is, yeah, so you have to opt into the compiler diagnostic caret. So turn that on yourself.
Should I even enable it? I expect it to be enabled by, well, I said not to have this option, just that's how it goes.
Right, but there's already code bases. Remember that we're trying to make sure that the upgrade thing is smooth. So there's code bases out there that this could potentially have broken if we gave you that error just out of the blue. So we want you to enable it.
People search the build output. They have scripts run over the build output. We start putting in carets. It just messes it up. They think their build's failed.
Eventually, but we need to have a time.
So this option only affects how you log stuff,
Correct.
not how you compile stuff.
Right.
Yeah, so the diagnostic.
People who write tools have built books. Yes.
All right, so unless there's any other pressing questions, we'll move into the Visual Studio portion. So this is where I ask, how many people here are not using Visual Studio 2017? Don't be shy. Actually, there's quite a few. All right, so now you're going to see why you really, really want to move to that and go convince whoever it takes to go do that. And for the rest of you that are using it, you might learn a thing or two as well. So the first thing to talk about are the release cadence. And I didn't even put all the releases up there at the top, but I touched on those as I was talking about the MSVC part. We ship very frequently, in case you haven't noticed. So it's a new world. We ship very frequently, which gives us the opportunity to release more value. And as you report issues, it's a smaller turnaround time because we'll ship soon after. Now, the first thing you'll encounter when you go and get Visual Studio 2017 is the screenshot that I've got up there. Now, this is not just a redesign of the UI layer for our installer. It is actually a big architectural change behind the scenes, because this is what we call a workload-based installer. So that means you go and pick your workload, which maps to one of these tiles. For example, here I've got selected the desktop development with C++, and then you get to install only the things that you care about. Now, why is this awesome? Well, there's 3 reasons. One is that we'll put less stuff on your disks since you've actually selected specifically what you wanted. There isn't one big default. So that's good. Because we're going to put less stuff on your disk, it's going to be much faster to install. So that's also good. And because you've selected exactly what you wanted, there's not going to be any visual noise of things that you didn't want. So for example, if you select this workload, in under 12 minutes, you'll have the Visual Studio installation you always wanted for C++. If you didn't care about C#, you're not going to see any of that stuff, and your disk is going to thank you for it as well. Now, there is a fourth reason. If you look on the side, you can customize each one of these workloads. You can customize the defaults. And one of the options that I'm highlighting now with the arrow up there is that now you can get the Visual Studio 2015 toolset without getting the rest of the Visual Studio 2015 ID. This is huge for the reason on the next slide, which is we really wanted to make sure this is a very, very easy upgrade. If you go and select that option, essentially when you then go with Visual Studio 2017 and open your existing projects, you just don't upgrade them, and now they're using the old compiler while you're taking advantage of everything that's new in the IDE itself. It cannot get easier than that in terms of moving to the latest IDE. So that is huge. Now, some of you may be thinking, that's great, but you've just been talking about all the value that you have in MSVC. I want to take advantage of that, conformance, performance, and so on. So I will want to do that. And when you want to do that, you'll go to project properties, and just like the screenshot shows, you'll select the latest compiler, and now you're in business using the latest bits. Now, if someone heard this that was out on the street, not you guys in this room, they'll be thinking, oh, but now I've thrown the new compiler, I have all these cleanup I have to do in my code because you're more conformant and so on. But you guys are not thinking that, because earlier we talked about compiler switches. So you remember that you can actually go and take as much of a chunk of that as you want with the appropriate compiler switch and go at your own pace. So now some of you may be thinking, and I'm saying this because we've heard it from customers, is I love this. I love embracing all the new stuff and cleaning up my code. However, I depend on third-party libraries. They're not moving forward, so I can't move forward. Essentially, third-party libraries that are not built with the latest compiler that you want to use are holding you hostage to the old compiler. And that is why for the first time ever that we've managed in this release to have binary compatibility between the two runtimes and the two toolsets. And what that means, to spell it out, is that that third-party library can actually stay built the way it was with the old compiler, while your call-in code that uses it can move forward to the latest, and that will all still work. So you're no longer held hostage from that. This is a huge thing that not everybody understands when they're thinking about a pain of upgrading and thinking of third-party components. So that's something to take back to the decision makers at your companies. Now, at this point, someone may be thinking, well, I use some open source libraries, and I do want to get the latest. There's all kinds of goodness in the latest versions of these libraries. Do I have to go and clean them up all on my own? And I wouldn't be asking that question if I didn't have an answer. So the answer is, no, you don't. There is VisiPackage. And if you're thinking, what is VisiPackage? Well, there's a whole slide on that. So VisiPackage is something that we announced last year here. It's 1 year old now. And it's a free open source project, which is a repository of open source libraries, which are growing every day. And you can go there and find the library that you depend on, and it will already be built with our latest compiler. And if you have a library that's not there, that you'd like to be there, email us and we'll take care of that. Now, if you want to learn a lot more about VisiPackage, then you'll want to go to tomorrow's Open Content Talk at the friendly time of 8 a.m. And that's where Robert and Eric are going to talk more about it. You're also going to see it in action now, as Steve is going to demonstrate everything that I've talked to up until now for the Visual Studio parts, including a bit on VisiPackage. And then I'll come up and we'll talk more about other stuff. Are you ready, Steve?
I am. I'm ready to push the button.
All right, Steve, over to you.
All right. Hey, look, code. All right, so I'm going to just walk you through that process. We were having a sort of pre-show here where we were discussing the fact that there's only so fast you can get people to understand that something has changed important in the world, and so we really wanted to stress this point. So I got a 2015 solution here, and this project has a dependence on a one third-party 2015 library. So as you can see, this is me opening it for the very first time, and I'm going to be given the retarget dialog. And so, we want you to go forward, of course. And so, the first thing we do is we give you the option to move to the latest Windows SDK and the latest platform toolset. So 141 in this case represents the VS 2017 stream of compilers. But to get started, I want to show you that, of course, that's not necessary. You can click no and click OK. And again, it's been like that for a long time. And it's amazing how many people don't know. So as you can see up here, now it is a Visual Studio 2015 marked project, but this is 2017, and everything just works. So if I go here, I get full IntelliSense. I can go jump to definition. All of these things work. And if I have this machine set up the way Daniel had in his slide, where I've installed the VS 2015 Update 3 toolset from this, rather than installing all of Visual Studio 2015 on this application. So what I'm going to do, this is basically a little graphics demo. So I'm just going to show you that it actually will work. It's going to build with the Visual Studio 2015 toolkit. And then if I run it under the debugger and you look very carefully, I want you to stare very closely at this until you are all hypnotized. Upgrade to Visual Studio 2017, upgrade to Visual Studio. All right, so that works, right? But now what I want to do is I want to walk you through all of the steps to get yourself to sort of like modern happiness, right? So the first thing I want to do is, hey, I dismissed that dialog before, and I want to make sure, in case you did dismiss that dialog before, that you know how to get it back. So if you click on here and you go to Retarget Projects, it will again give me that, because the next time you open it after you've dismissed this one time, you're not going to see it again until you select it manually. This time I'm going to accept the defaults. I'm going to take the latest SDK, and I'm going to take the latest version of the compiler. You can see up here that the marking is gone, because this is now a 2017 project. I'm going to go ahead, I'm going to build. And amazingly, this is actually going to work even though I have that statically linked component in here. And just to show you how that worked, right, I just want to make, nothing up my sleeve, magician style here. I'm going to go in here, I'm going to show you inside the linker, here's where SDL2 which is the name of the static library that I've done in here. So that is still getting picked up. That is the 2015 based static library. And so I built it, and now again, if you do that, you can get hypnotized again and more likely to do it. Great. Okay, so that's great. So the next thing I want to show in here, in your process of taking your old code forwards, as you pick your time, is come in here into the project, learn how to use a mouse, trackpad in this case, and then if you go into here on C, C++, you go down to the language thing. This is new in VS 2017. It's the first time we've ever had language specifications like this. And so if you click in here, the default will be C++ 14 because that was the newest existing standard at the time that we released RTW. But now you can select in here and choose the 17 spec. So I'm going to do that. Again, I'm going to go in here. I'm going to build. It's going to work. There's not any breaking changes in this. And now if I go in here and type, include optional or whatever your favorite header is, and build, again, that will work as well. Okay, so great. So what do I want to do next? The next thing I think you want to do with your code is take advantage of the fact that we are locking your code into the non-extensions version of pure C++ 17. What I'm showing you right here, these bits that you'll see for these first couple of demos are all 15.4 preview. And in 15.5, we will add an official thing for this, but for now, whenever you want to, you can add a permissive minus here in additional options. And again, this will lock you in so no one accidentally adds some sort of one-phase lookup-based code into your code base. So you kind of get clean, get the RS3 SDK, and then go forward. Again, it just works. All right, so I'm pretty close at this point.
Can you use a Microsoft extension and recompile this to show that it fails?
Not in this demo with the amount of time I have left in this talk, but come to the booth afterwards, Zach, please. Okay, because I think I'm not cheating. So the next thing I want to show you is VC package. Okay, so we talked a little bit about this. This is the VC package webpage. It's as easy as go to GitHub, look for VC package, and it's like basically a batch file. Clone this thing and bring it down. But the magical directory in here is this ports directory. This will tell you all of the things in here. Is Eric in the room? He is not. But if he were in the room, he would tell me that there are now, I think, 352 different libraries in VC package. Like we went from 0, or we launched with 19 or something, to 300 actively maintained packages in like 9 months. It's been fantastic. And as you can see here, I have SDL2. So that's great. I'm going to go in here, and I did it offhand because what will happen if you type this is it will actually pull it down, apply some patches, and build it, and get it locally installed. So I have SDL2 installed locally, and then what I did was VC package integrate install. What this will do, so what it says it will do, is it will make it so that any MS Build-based project will be able to pound include anything inside of that, as well as linking will just work. And so let me demonstrate that. Of course, in this particular case, because I already had it in there, the 2015 version, I want to replace that one. Perhaps there's been a security thing. Perhaps you want the version with the latest performance. So if I go back into the linker and input and delete out SDL2, and again with the learning to use a trackpad, and hit enter, and I rebuild it one more time, now it will rebuild against that VC package version, and now everything is 2017, everything's latest spec, and everything is no extensions. So yeah, thanks.
Thanks, Steve.
Daniel, back to you.
All right, so we talked there a whole bunch about upgrades, so your existing projects, but some of you said that you're not using Visual Studio at all. So in fact, let me test that. How many have C++ code bases that you don't use Visual Studio at all? I see a really proud hand, and someone is like more, like, can I say that? Yes, you can. So we hear that rarely. It's shocking, but it happens. So we found that one of the reasons is that folks use different build systems, and Visual Studio is very much MS Build oriented, or has been traditionally. So that's been a blocker. It's perceived as too much hassle to bring it into Visual Studio. So for that reason, we went and invested in what we call Open Folder. So Open Folder is exactly what it sounds like. You take Visual Studio and you point it, you browse to your disk, find your C++ code base, no matter what build system you're using. You hit open, and now that code base is in Visual Studio. Now you may want to get some richer IntelliSense, maybe debugging, maybe you want to build from Visual Studio rather than from the command line. In those cases, you just type a little bit of JSON to let us know some information that we need, and then you can get the full Visual Studio experience with your build system of choice and without having to go anywhere near MS Build or Visual Studio projects or anything like that. Now, a special case of that is CMake. So I say special case, it literally is a specialization. You'll browse as I just described, and if we detect that that's a CMake-based code base, you don't even have to give us the JSON little files. We'll just do that automatically, and you will get a native CMake experience out of the box. I want to stress that it's native. It's not generating a project behind the scenes something. It's a native experience of CMake in there. So Steve now is going to demonstrate both CMake and the open folder. So Steve, over to you.
Okay, so back to this. So rather than going in and collecting open project, I'm going to click open folder. And so I'm going to go on my disk, and all I have done to prep this, literally all I have done to prep this, is do a git clone on bullet 3. Now, this is for our Google friends in the front rows who are not using Visual Studio. This is a code base from Google. It's a sort of a bullet physics thing. And because they don't use Visual Studio, there is no like Visual Studio solution or anything in here that we are using. So all I have done is pointed it directly at that folder. And because it does indeed have a cmakelist.txt file, when we open the folder, it will detect that. It will light up the IDE and get all the configuration information it needs from the CMake server. Now, I want to be clear. We're not like in the background doing the CMake generation of a solution file and then opening that up. This is like real. It will go in, it will detect CMake, switch into this mode, and use the server thing. So to get started, let's take a look at the cmakelist.txt file. This is the main one for the project. As you can see, we get some colorization going on here, and indeed, if I come in to this file and start typing, I do get some helpful IntelliSense in there. So that's nice. I want to be clear that I didn't do any configuration for this at all. And indeed, if you wanted to do some, what you would do is you would come to this cmakesettings.json file. And this sort of takes the place, if you've ever used CMake from the command line before, of the place where you would kind of put on the command line stuff. And if you look in here, I've got a bunch of different configurations, right? You can see that by default, we're using the Ninja generator here. That's the default one. But if I come in here and I type this, you can see I have the ability to use the Visual Studio generators for 14 and 15. So I'm going to get that back out of there. Again, sort of to prove that there's nothing up my sleeve, I'm going to show you that all of the UI features that you would expect in the open project or solution scenario still work here. I can use the new cool Find All References experience inside of Visual Studio 2017 with this, and it just works. This particular project has a number of different targets, and so I have selected the one called App Basic Example GUI. And again, for Visual Studio, because it's an IDE, I think to sort of prove that this is a full-fledged experience, I'm going to kick off the debugger here. I'm going to click that. I'm going to hit this breakpoint. I get all the sorts of usual Visual Studio experience that you'd expect here. And then if I kick it, you'll see some blocks break up, and okay, great. So that is how CMake works. It's more or less, it just works. So the next thing I want to show you is CMake is intended to be magic, but not everything can be magic. Sometimes you have to tell us things, and this is an audience of C++ developers who like to tweak things, so let me show you how to do something a little nuttier. I'm going to use Visual Studio to build, have IntelliSense build and debug using GCC with MinGW and MSys from Visual Studio. So I'm going to go here, samples. I'm going to go choose my MinGW demo. I will warn you that it is a very simple MinGW demo. Okay, so I'm going to walk you through very quickly the 3 files that are necessary to unlock this behavior if you want to use Visual Studio with something a little bit more exciting like MinGW. So the first one is CppProperties.json. I want to be clear, Will, back in the back of the room here, wrote a blog post. If you go on your favorite web browser and search for Visual Studio and MinGW, you will find basically the template for how to splat some environment variables into here. So I literally took that and put it in here. There are 2 halves to this file. One of them is just about setting up your environment. Obviously, if we want to build with the MSys/MinGW environment, I need some access to some of those environment variables. You can either launch this Visual Studio so it will inherit them via the MSys shell, but what I've done is I've copied those environment variables into here directly. The only line in this I changed from the template on Will's blog post is the GCC version. I wanted a more modern one, so I updated the version that was inside with Pacman for MSys. And the only other thing I did is down here in the configuration section where we create the MinGW32 version, and I had to tell it, of course, where on disk I had installed this. Okay, so once you have CppProperties.json installed, then you've got everything you need in order to be used full semantic Visual Studio IntelliSense. So just to demonstrate that, I'm going to again go to definition. So I went to definition on cout, but the key thing to know here is that it brought me to the right IO stream. You can see that this is the one, the MSys64 version of MinGW32 for the version of GCC that I used. And all of that's unlocked just by setting a couple of environment variables and putting some boilerplate into that thing. Okay, so that's wonderful. So now we've got IntelliSense, and so you can edit code. If you've ever used VS Code, this next JSON file will look familiar because they're very similar. Task.vs.json is how you specify any custom tasks that you want to run, but the most common one, of course, is build. And this context type : build here is what tells you basically, hey, Visual Studio, wire this up for all of the build commands. And here you can see in this one, because it's super simple, I'm just doing a G++ command line directly. But in other examples of this that I've done myself, you would just basically put the word make here. And then once you do that, if you right click over here, now we can build main CPP, and it will use MinGW to build that and pipe back the error messages as you have. Again, Visual Studio, me and Daniel are biased. We both used to work on the debugger. So the next thing I want to show you is actually full MinGW debugging inside of Visual Studio. So as you can see, I right-clicked on this. I went to debug and launch settings, if I did that a little too quickly for you. The three on the bottom are the classics. These are Microsoft's compiler and debugger things if you want managed, mixed, or native. But we've got two new ones. One of them I'm going to show you in a minute called the GDB for Linux one. But for right now, I have selected the one that matches up to MinGW and GDB. And now, when I go into the program, and assuming I have this set up right, which I'm not 1,000% sure I do, there we are. And so this is debugging with GDB inside the Visual Studio IDE on a MinGW application built with GCC. All right, thanks.
Nice.
Thank you.
And we're only 6 minutes over. It's great.
Whoa, okay.
Okay, so just orientation. This is where we are. We've done everything up to the green arrow. And now what we're going to do is very quickly, and I do mean very, very quickly. As you can probably tell, I can speak fast. I can also turn it up a notch. I'll try and do that now. We're going to go and look at the other workloads that are in that installer, the Visual Studio 2017 installer I showed you earlier. So one of them is the Universal Windows Platform Development. So those of you that want to do UWP, you need to go and check the C++ box. It's not checked by default, so that's my tip for you. And in case you don't know, we do have a unified Windows store. I think it's really cool because you can create a single binary and it will run on desktop, mobile, Xbox, HoloLens. It just runs everywhere. And at runtime, it actually adapts to the form factor and the input types of the platform that it runs on. Also, you see up there C++ WinRT. There's a session on that this week at CppCon, so you can check that out. And the last thing I'm going to say on this slide is that bottom bullet. We've had from the previous release, in fact, a way for you to set up Visual Studio to share code and target as many platforms as you want, like Android, iOS, and Windows. And now, new this year is that we can also have Linux targeting from there. And Steve is going to show you that in a minute. So moving to the mobile development with C++ workload, and I have to say, in case I haven't already, you can combine these workloads, right? You can check as many as you like to create the combination that's good for you. So in this one is the one where you're going to target Android and or iOS. This continues to work like it used to. We can still round trip with Xcode if you're doing iOS development. And on the Android side, we give you full IntelliSense and debugging, not just for your C++ code, but also for Java code right there in the IDE. And we do updates to later API levels and NDKs. So we're looking for your feedback. For those of you that have tried this, what else do you want us to do here? So just come to the booth or grab us if you see us and let us know what else do you want to see in this mobile development with C++ space. Moving on to the Linux workload, which is the latest one to join the family. This is new in this Visual Studio 2017 release. It was only an extension before. And this particular workload, if you select only this one, in under 6 minutes, you'll get a Visual Studio installation that gives you all the Visual Studio goodness of debugging, editing, and so on, but targeting Linux. And last year, we did a really cool demo of this, and by we I mean Steve, of the Windows subsystem on Linux. Since that time, then it was like a beta kind of thing. Since that time, with the Windows 10 Fall creators, that's actually released. It's fully out there now and on Windows Server. And that essentially allows you to have multiple distros running concurrently on your Windows box. You don't even need a separate Linux machine or a VM or anything like that. So that's pretty awesome. But we demonstrated that, so we don't want to demonstrate that again. So instead, Steve is going to show you that sharing of code with Linux and Windows and some other things that we've recently done for Linux. So Steve, over to you.
Okay, great. So as you can see, this is Ubuntu 16. I've got it running inside a VM on side of my machine. We're much further along than we were last year when we showed you something. So this year, I want to show you shared projects, and then I got a little something at the end. So again, if you missed last year, how this works is you go into Connection Manager, and you click the Add button. All we need to know is the host name, the port, the username, and some sort of authentication methodology. I have previously set this up, so the default one is now pointing at that VM here. I have it on an internal Hyper-V switch on my box. Okay, so the next thing that's different this year from last year is cross-platform cube here. This is using shared projects. You see this double diamond thing. This is a shared project, and then if you look inside of my not that one, and you look inside the references here, you can see I have two other projects, one called Windows Cube that has a reference on that shared project, and one called Linux Cube, which is a Linux project and has it on the same project. So there's basically only a single source file in here, but that source file is shared between the two of them. So I'm sure you can imagine what this looks like on Windows. So just to sort of get it built and get going here. This is a rotating cube. It's not a demo unless a cube rotates. So we got that going for us. But the other thing that you can do here, of course, using that same technology I was just talking about in the last demo, was if I go and I click and debug the Linux one and find the right place and wait a second, you can see here's the cube debugged with GDB on this. Okay, so the most important productivity feature for this is, of course, the quality of the visualization of any debug things. And so we do indeed have visualized views. So when you're debugging from Visual Studio, you'll get a nicely visualized version of that thing, not necessarily what the raw implementation looks like. So that's very useful. Okay, so as you saw, at least on Windows, that was rotating pretty quickly. So I'm going to go in here and demonstrate for you very quickly what I think is a really cool IntelliSense feature for these cross-platform scenarios. So I want to slow this down. So I'm going to type usleep 1000 in order to slow down the thing. Okay, so you see this purple squiggle? Okay, so red is bad squiggles, right? But purple squiggles are different. Purple squiggles are moderately bad squiggles. And if I hover here, you can see exactly what's going on here, which is, yeah, that's great, Steve. You can use 1,000 microseconds and sleep for them. But there's actually not an equivalent function inside of Windows. You'd need to use the capital S sleep, which obnoxiously uses milliseconds instead of microseconds. So this is telling you before you've even built that you have a non-cross-platform clean thing inside your code, and you can go in here and add the appropriate FDEFs or whatever. So that is the cross-platform cube, and that's shared projects for Linux. But I actually kind of dropped a little bit of a Easter egg in an earlier demo. So what I'm going to do now is I'm going to go back and I'm going to reload the open folder on bullet 3. And again, I want to stress that I did not change the settings on this. But if you saw earlier as we were looking at the configuration, there's actually 2 at the bottom here. And this is new in 15.4 for sure. And so what happened there is I switched to the Linux debug configuration, and now CMake is sort of switching configurations. You can see it's changing the IntelliSense to point to the Linux-based versions of things instead. And now if I select the right, I think it's that one, and I click build, you can see it does a build. The build is happening remotely, remember? And now, it's going to hit a breakpoint because I set one. And now, you can see the slowly emulated cubes breaking apart inside Linux with no reconfiguration at all. You're just switching back and forth that one switcher, and you're getting from Windows mode to Linux mode. This is super useful. All right, thank you. Daniel, back to you.
Cool, thanks, Steve. You guys like that? Is that cool? Yeah, that's what we like. See, if you beg the clap.
Shameless we are.
Yes.
We are shameless.
So something related, the Internet of Things, IoT, when those things are running Linux, obviously everything we showed you applies. So if you're doing any embedded or IoT kind of development and you've got Linux targets, all of the stuff we showed you just works. That's definitely a scenario that we are prioritizing. And we've got improvements in that, like with the Yocto SDK allowing you to replace the compiler that you would want to use. Last year we said that we intend to also add support for microcontrollers, MCUs, and indeed in 15.5 you will start seeing some of that. So good news here for embedded and IoT developers. Now IoT, Internet of Things, so these things are connected, and if you're going to connect them to something, then we encourage you to go and check out the Azure IoT SDK, which supports your IoT needs. And now from here, I'll switch to the last workload that our team kind of develops and we think it can be useful to you, which is one on game development. So notice how at the top there is the Unity workload, and then all the C++ related game development is in the other workload, game development with C++. And that includes DirectX and Unreal, Caucus, the game engines that we support out of the box. So this is also an area where we really want your feedback. What else do you want us to do here? We've been working on this for a while. It's fairly mature. Is there anything missing? So come and find us at the booth or stop us and let us know. I will say before I move on from this slide that more and more these days, game development, those games are powered by some kind of cloud service. And there's a URL up there on the slide so you can find out what the Microsoft Cloud can do for your games. And with that orientation, we've got 2 slides and a demo to go. So we're going to go and dive straight into productivity. And this is the bucket of all the things that make the quality of your everyday developer life better. These are things that you do every day when you go and develop code. Last year, we had a 15-minute demo of just productivity features. So we showed you a lot. But since then, we've done even more. So Steve now is going to show you some of those newer things. And I think he's going to be using 15.5 for this one.
Yeah, this is the 15.5 bits. These you can't get yet, but I promise they are coming soon. All right, so the first thing I want to talk about, I've got a cryptography thing, again, just some code we cloned off of GitHub to do the demo with. The first thing I want to talk about, which is a sort of like productivity feature we don't talk about as much in these situations, which is just your source code control. So Visual Studio has a quite sophisticated set of bindings for Git, and so I'm demonstrating here. I went in here and I clicked View History, got the full history of master in here. A new feature in the 2017 line is if you select 2 different commits, and you can right-click in here and click Compare the Commits. It will bring up the Team Explorer with those 2 compared. That'll tell you, of course, what the messages were for each of those commits, but also it will give you just the files that were changed in between those 2. And now when I go in and I select one of these, I can see the diff of that file between those 2 things. And it doesn't matter which version I have checked out. It will just give me the difference between those 2 commits. I think this is pretty useful. Let's be honest, most of the purpose of source code control things is blaming other people for problems. Oh, good. I'm glad that you do too. So we also have a very nice visualization for the git blame thing. It's fun to go through other people's source codes and do this on them. So like in this one, I noticed as I was going and prepping this demo that this person, Wei Dai, had gone in and wrote a bunch of code. But this guy, Jeffrey Walton, had gone in and added a bunch of asserts. And then it made me think, oh, I want to hire that guy. All right. So that was good. I'm sorry if any of you are in the room. I just picked this randomly at GitHub, and now I'm making fun of you on stage. OK, but does anybody test their code? Oh, that laughter was uncomfortable, people. All right. So we've noticed, actually, that many of you don't use the built-in unit testing inside of Visual Studio. And we've done a lot of work in Visual Studio 2017 to try to make it much better for the average C++ developer. And so it's coming in 15.5. We're going to have support for Google Test. That's like you guys sat there on purpose. Google Test as well as Boost Test are now going to be in box with things. Before you had to use our test adapters, and now we support others. So the way that goes and works is if I go into the Solution Explorer, and you click on your solution, and you go Add New Project, one of your choices, one of your project template choices is Google Test. If you select OK to add that to your solution, you can then select which project inside that solution you want to test, as well as decide whether you want to consume it as a static library and how you want to consume the runtime libraries. So I've already gotten this set up. In the interest of going fast, I have. I'm a solid programmer. I wrote 1 test for this entire code base. And as you can see, what happens is this gets detected. Your code base, once you have this in there, if you have gtests stuff in there, it will scan your solution to find them. The Test Explorer will find them. And then you can click this, it will run. I believe you can see it's, okay, so it's building first. So let's all wait patiently for that to happen. Now the tests have kicked off. You can see that the test has failed. It gets all sorts of good information when a test fails so that you can see, like for instance, if it's thrown an exception, there's a whole logging thing in here, which is great. You can click on here to debug it once it's failed. But the thing I want to show you right now is a feature after my own heart, analyze code coverage for all tests. So I'm sure I'm doing quite well here because I wrote that one test. So it's kicked off. So it's going to build it again. What's going to happen is it's going to instrument the code, all of the code, and then run that unit test against it. And then it will tell us how we did in terms of our code coverage. Running one test now. I'll tell you that this is the first piece of code I ever wrote at Microsoft. So I'm very, okay, 14 years ago. So you can see I'm doing a fantastic job. I can see immediately across my entire project I have 7% coverage. So I think that's done. Let's ship it. All right. Next up. All right. I want to show you just one or two more quick little things. The first one is going to be, where'd you go? Functions stepping before. Okay. I've got two features left I want to show you. One of them is editor config. In case you don't know, while that's loading, I'll tell you that editor config is like an open standard for expressing what your desired editor formatting choices are. And you can see I have it in here. We talked a little bit about red squiggles and purple squiggles earlier. This person who has written this source file has selected tabs, and so I'm surprised there isn't a red squiggle here, because that's just not right. I was hoping to get booed or something for that one. So I go in here, I'll save that. Thank you for playing along at home. And then it will quickly change the code to match that editor config. So this is a good way, nice cross-editor way of setting up what your preferences are. So the next thing I'm going to show you is a surprisingly highly voted feature on user voice, and so we finally dealt with it. So this is actually the before picture, so I hope you can bear with me on this one. So what we have here is three functions. We have a plain function, a member function, and a function object that returns a witty pop culture reference. And if we go here and we run to that, yeah, let's go ahead and build that. So let's get to that point in the breakpoint. Okay, so this is a stood function wrapper around plain function, right? How many times do you think we have to step into before we reach plain function? Okay, think of a number in your head. All right, okay. 1, 2, okay, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18, 19, 20, 21, 22 is actually the correct answer. Who had 22? Of course you all did. I didn't make you write it down. All right. So, and indeed, the climactic conclusion to this demo is coming in 15.5. You will have the following experience as soon as your solution loads. Just one sec. Come on, man. This is killing the suspense. Is this building suspense or killing suspense? I can't tell. What's your guys' feeling? All right, so I got the breakpoint set. Let's go. All right, F5, yeah, build it, sure. And 1. All right, that's it. Thanks. So that's function stepping. If you use stood function, it's going to save your life. Think of the children. All right. If you have to debug the implementation of stood function, you work for me and I pay you enough. Yes.
How do I get this technology for my own big template wrappers that have many levels before they call?
So I will say, go to the Visual Studio booth afterwards and say these words, and I swear to God it will work. Say, can you tell me more about Project Fifi Fufu? All right, go. I'll explain later.
Thanks, Steve. And by the way, we keep referring to our booth table. It's literally around the corner from here. So just go out, turn right, and just find the purple shirts. And we'll answer any questions that you have. And also requests. If you have requests, Steve showed editor config, which is like a standard. Maybe you want to see something else. I don't know, client format, something else. Just let us know. He showed the Google test and Boost, and obviously we have MS test. Is there something else you want to see? I don't know, catch, like something. So just let us know what else you want us to do in all of these spaces. We're just around the booth, and you can also email us, like I said earlier. All right, so we're talking about productivity, and some could argue that performance is part of productivity, especially the performance of the AD as you interact with it. Like earlier when he was killing the suspense, you want it to be fast. So we talked about build throughputs earlier. That's part of that. As you do the edit, build, debug, you want that build step to be as squished as possible so you can be productive. But we've also done other improvements, and we shared these last year. I'm curious, actually, how many people were in this talk last year or saw it online? Can I see your hand?
Yeah, diehards.
That's not everybody. We could have repeated the same demos. They wouldn't know.
It would have saved me a lot of time.
Yeah. So then actually I should stress, look at these dramatic improvements. I was going to pass this by, but you don't even know about this. Look at those numbers in terms of solution load, 17 times faster. That's crazy. So we've actually invested a lot of energy here in the performance of the ID itself. So like we like to say, this performance you'll be able to feel. Now, and we're not done. So internally we're working, no, we don't have time. So we've got bits where we're improving the design time experience. Think of go to definition, find all references, refactoring. So our goal there is to go orders of magnitudes better than where we are. And I can say that easily because it's his team that has to do it. I'm just a program manager. That's the specification. Make it orders of magnitudes faster, Steve, now. So this is an area that we're really trying to improve. So again, we want your feedback. What are the scenarios when you use Visual Studio and you're like, oh, I wish it was faster there? Just let us know because we're really prioritizing this. All right, so with that, before we go to the summary, there's only one more slide, which is really to thank all of you folks, because these are the two primary ways that we like getting feedback, and you've used that. So on the user voice with your suggestions and votes, and through reporting problems in the tool, you have told us about issues, and we have addressed them. And this is the number of votes that we have closed and bugs that we have fixed just coming from you into the tool. So give yourselves a round of applause, really. Thank you very much if you hadn't told us about it, we wouldn't have fixed them. So that's in addition to everything else that we do. So with that, this is the last slide. So we talked about all of these things, conformance, performance, Linux, Android, iOS, IoT, game development, just like throwing words out there. CMake, basically, like I said at the very beginning, we want Visual Studio to be the best idea on Windows for targeting any platform, any scenario that you have. And our compiler to be the best compiler on Windows and libraries toolset that is on Windows for Windows. And that's what we're doing. And there's also Visual Studio Code, so catch that recording online. The last thing I'll say is that I don't know how many of you have been following kind of what Microsoft has been doing over the last few years, but it's a different company. From the inside, we feel that, and we're happy with it. I hope you guys can sense it on the outside as well. I don't know how many people would have expected that we would be shipping a cross-platform free open source editor. Like, who would have thought that a few years ago? And it's actually the number 6 project on GitHub in terms of number of contributors. I looked that up over the weekend. Also last year, Microsoft was the number 1 contributor on GitHub in terms of open source contributions. It's a different company. I hope you've seen some of it here, but that we can always do more. So please do come talk to us. What else can we be doing to be better citizens in the community and to offer better products for you? You can email us. Again, any abuse, Steve Carroll. Any compliments, Daniel Moth at Microsoft.com.
Yeah,
Enjoy the rest of the conference. Thank you.
Yeah. Okay. Wow, we didn't screw up the time, did we?
No.
All right.
Someone we forgot to say something important, I'm sure.
Yeah, probably.
So we have 2 minutes for questions if you don't want to come to the booth and you want to ask them now.
Kostya, what's up?
Do you have any new features for memory safety?
New features for memory safety. I don't think anything that we want to talk about short of the CPP core check stuff, which I guess you could look at as that for, yeah. Not at this time, sorry.
I have a feature request.
Okay.
This is probably going to be like completely insane, but like, you know how you have the immediate window in Visual Studio?
Yes?
I want to be able to type Windybug commands into there.
That's not a crazy...
That's not a crazy thing at all.
Okay.
No.
Can you do it?
Well, we've heard you.
Okay.
Yeah, find McNellis.
Okay.
And
also,
me, and we'll
there's also the Windybug guys are here.
Yeah.
So you can also ask them, because it will be a collaboration.
Okay. The other thing I wanted to ask is the like you mentioned the Google test adapters and stuff.
Yeah.
Does that work if you just open a folder that's like a CMake project and then it discovers a Gtest project in your tree?
Not yet.
Not yet. Do you want to speak to that, or
So basically, in order for the test platform,
in the microphone though? Yeah.
See, he'll tell you why it doesn't work yet, but it's on our plans.
I just want solutions.
So-
I don't need reasons.
yeah. So basically, the core test platform of Visual Studio currently doesn't support open folder. We're hoping to change that in the future so that it is supported in any environment that you happen to be using. And at that point, once the test platform supports it, then we can make sure our test adapters actually support open folder mode.
We're definitely going to keep going on testing. Like we're just getting started. Yeah.
Okay.
Hi. So I noticed that Unreal Engine was in the list of platforms or projects you're testing permissive on, but they have their own build tool,
Yes, they
UBT, that doesn't let you pass in your own arbitrary parameters. So how are you dealing with that?
So that is a very good question. I do not know the direct answer to. I can get, if you grab me afterwards, though, I can find the developers who have that thing set up and see how they're hacking.
But
that
it's
one
true
in.
for a lot of the libraries and the real world codes that we test internally. It's not that publicly you can just go hit the button. We have to do work to get them into our compiler.
There's like a decent number of people working, like just to make sure that that keeps running, because we just think it's so important, and especially with going fast, with releasing updates that are in place, it's critical that we not make mistakes, and so that's why we invest in doing that more than we have in the past.
So I think we're over time, but we can take one more question.
Hey, Vishal.
Yes, I wanted to ask, is there any plan to have the Visual Studio's compiler run on a non-Windows platform so you can build the Windows tools that or create automated builds to build the Windows tools that are Windows applications, or run even the native unit tests without actually having the Visual Studios running?
No.
But you should talk to Zach. Okay.
That's a short answer.
Yeah.
No, and there's no plans for that at this point.
Yes.
But if people keep asking, you never know.
All
right
right.
now, people are not asking.
So we'll be around for as long as they'll let us, and thank you for coming.
Thanks.